Welcome everyone to our presentation on creating things with a CNC machine. This video will take you through the process of taking an idea, design, or image and using a CNC machine to produce a physical copy. Included in this video will be a brief introduction on CNC machines, an overview on how to take a design and get it ready to be carved on a CNC, a look into CNC project connections with curriculum outcomes, and finally, a demonstration where we will show off a completed design after being built on the CNC machine. This next part will cover some of the basics on CNC machines. This portion of the presentation will take you through the types of CNC machines, hardware selection, safety information, and how to avoid some potential pitfalls. CNC machines are designed to remove material from a blank in order to produce a desired object. The cutting path of the CNC can travel horizontally, vertically, and can also be programmed to cut to different depths. Some very advanced CNCs can also rotate to cut from different angles. Several types of CNC machines exist. These include milling, which is the type that is used for our demonstration, laser engravers, and lathes. CNC machines have the ability to drill and carve. While the cutting hardware may look the same, drill bits and end mills serve different functions. What is important for the user is that they choose the correct bit depending on what they are asking the machine to do. You have a lot of materials to choose from, which all can be carved using a CNC machine. Wood, metal, plastics, and other synthetic materials can all be machined. There are several safety items that need to be considered when using CNC machines. Beginning with attire, you will need clothes that aren't too baggy, protective eyewear, and hearing protection. CNCs are loud. The amount of noise that these machines make can permanently damage one's hearing during use, so cover up those ears. General safety routines are needed when working with the machine. The hardware can be sharp, so attention is needed when using these items. Changing out bits and mills requires that the machine is turned off or completely disconnected from a power source. During operation, fire can result from jammed bits and mills getting stuck. When this happens, the friction will create a lot of heat, which can lead to lighting the workpiece on fire. So leaving the machine while in operation is not recommended. It is very important that the workpiece be secured to the CNC table. Without doing this, it is possible for the workpiece to move around, which could cause injury. Also, jamming can occur due to improper securing methods. Resulting heat from jams can ruin the finished product and also has the potential to start a fire. Being aware of where the bit and spindle will travel should be a consideration before operating the CNC. The potential exists where the machine can accidentally cut into the holding clamps and other important areas of your final work. One last consideration is to make sure the spindle won't damage your final product as it lowers closer to the workpiece. Keeping the final depth of cut in mind is important during the planning process so as to avoid this situation. To help you better plan for using a CNC machine, this next portion of the presentation will outline the beginning steps all the way through to carving the end product. There is a process to using CNC machines which follows the steps outlined here. It begins with a concept or an idea of what the desired product will be. At this stage, you will also want to select your material to be carved. At least one flat side is needed so that the workpiece will remain steady during the milling process. Please remember that the end product can be damaged or ruined should the workpiece move while the CNC is carving. Next, you will need to take your idea and get it represented in a digital format. AutoCAD, Tinkercad, and SketchUp are all great examples of software you can use for this step. These kind of programs are called CAD, or computer-aided design. You can see here how a design has been created both in 2D and 3D formats. Next, the design is transformed into coded instructions that will be used by the machine. This step provides machining instructions to the CNC so that it will know how to make what you want. Outlined here are some great examples of software which can be used in order to program a CNC for carving. A brief video is available in our PowerPoint which provides an example of the tool paths the CNC would follow to create a custom crib board. Once your instructions have been loaded into the CNC, it is time to fully secure the workpiece to the table, put on your safety gear, be close by to watch the magic happen, and make sure that it is operating properly. Once the CNC machine has completed your carving, the last step is to finish it and to make it look amazing. During this phase, you can bring out the quality of your work by sanding away any machine marks and other imperfections that remain. How you choose to finish your project can really make it pop. Sanding will help you further refine your work in order to show off what you've made. This will help to smoothen surface and edges, which will really bring out the details of your creation. Once the sanding has been done, there are a variety of finishes that you can choose to seal your end product. Depending on what you will use your creation for, some finishes may work better than others. Creating things using a CNC machine ties in with outcomes across many subjects and grade levels. This project also offers much potential for student choice as they go through the design process to finally creating something that came from their imaginations. As using the CNC involves creating or manufacturing something, it easily aligns with learning outcomes centered around using tools and building. Also, the design process is apparent throughout, as students are required to plan things out first before moving into the production phase. Using the CNC and following the design process also connects with the renewed curriculums for grades 7 and 8. Cross-curricular relationships are present as design is included in both science and technology education. And now it's time to show you an example. Our group chose to use the CNC to create a sign with carved inlay. This next portion of the video demonstrates how this was accomplished and the completed product.
Hey, welcome to the workshop here. Today, I was just about to do a CNC inlay project, so why don't you join me and I'll guide you through it. So, first off, if you're not familiar with the CNC inlay, what we're going to do is take two different pieces of wood. We have a nice darker color and a nice lighter color. We're going to do reverse carvings on them, smash them together, and get something beautiful, kind of like this. So I've been messing around with some ideas of what I want to do with these pieces. We're going to make a little sign for a music classroom for Huskin Studio. Alright, so let's get started. We're going to do the computer-aided design part, the CAD part of our program. So I'm using VCarve today. You can use the software of your choice. Now, I know from experience that when carving this, I want to leave a little bit of room on the outside. So I'm actually going to take this image, I'm going to shrink it down just a little bit. So next up, we're actually going to take this and we're going to do a tracing of it. It's a nice feature of VCarve. So right here's the icon, trace bitmap. Hopefully, if you're trying a project like this, you've done projects where you've done this before, but I'm going to guide you through it. So I'm going to click that, and now you can see it's highlighting my picture. It's kind of faded. I'm going to go to black and white because it's a black and white image. I can kind of tweak things here, but before I do, I'm just going to go down and click preview. And you'll see that it drew lines all the way around all of my pieces. Now, if I zoom in, yeah, it looks pretty clean, looks pretty nice, but this part right here, it's kind of creating these like little spots, and I don't really want that. So if I go to the features here on the left, I can both get rid of some noise, but I can also change the threshold. And by changing the threshold, if you watch over here, when I slide this up, you'll notice it start to darken around there. And so I'll try that, I'll increase that, click preview again, and you see how I've cleaned up that line nice and straight. I want to make sure everything looks good. I'll take a peek around the project, but I'm looking for nice smooth lines. For a project like this, thicker lines is also better. So I'm going to highlight what I want to carve, which is, well, that stuff we just made, and I'm going to use the VCarve engraving. So I'm going to click that. My next step is to choose, I want to have a start depth of 0, so it's going to start right on the surface, and a flat depth of 0.2. This is going to be very important if you're doing an inlay. Follow these dimensions. It's going to give you a nice pocket for the glue to sit in, for the two pieces to go together. Next, I'm going to take the piece that I want to carve it with. I want to use a V-shaped bit, and I've measured this one. It's 1/2 inch wide and it's a 90-degree angle. So I can put that here in my program. I'm going to go over, I'm going to select this one I've created. I've used it before here, 60-degree and 0.5 inches. Last thing, take a look at that bit. We don't need to use any flat clearance tool for this part just because we're engraving a small part here. We might on the second piece, but now that I have that, most of this I can just leave alone. I'm now going to calculate it, and it's going to calculate where the machine is going to go. The red lines here are going to show it traveling over the piece of wood. The blue lines are where it's carving. So it's important to note that it's starting at the bottom of the left. The tool is going to move from there. So I don't want to put a clamp on my piece of wood right there on that corner, or it will try to eat right through that. So I'll put probably clamps on the other 3 corners where the machine isn't going to move. Now that I have that, let's actually preview the tool path, and it'll show us what it should look like when it's carved. Now, it looks nice, but I know with an inlay that one problem that might occur is that these lines on the musical staff, they look pretty thin. Now, if we're doing an inlay, we want thicker lines. It's always going to be better. So I'm actually going to jump back to do the next part and actually thicken up those lines just a little bit. The image is one big piece, so I'm going to highlight it so it's in pink. I'm going to go over here to ungroup, and it's actually going to break it apart. Now I can select each individual part, and I can try to thicken those up. So I'm going to highlight all of those, and I'm going to use the offset tool down here. So offset, and I want to offset it outwards and to the right, which would make it a little bit bigger. I'm going to go a very small amount because it does take just a very little amount to create that growth. And I want to make sure I click delete original because I don't want both sets of lines. I just want the new thicker one. I can always undo it if I don't like it. So I put 0.02 inches. Let's click it. And yeah, you can see how it's a lot thicker. That should give us a little bit of a deeper pocket, but we're still seeing the image there. That's nice. I'm going to repeat that same step for the bottom one. Highlight it, click it. Still looking nice. Still we can see what it is. I think that's going to work out well. All right, so we got our machine set up. It's going to be able to carve it in here, but now we need the mirror image on this piece so that they can sandwich together. So, sandwich. All right, here we go. I'm going to take my image, and I need to mirror it. So I'm going to click Mirror Selected Objects, and we're going to flip horizontally so that it creates that nice, beautiful mirror image pocket and can sit on top. Next, we're going to create a little border around it. So I'm going to use the polyline tool right here. And I'm going to trace around the object, leaving some room where I'm going to be mounting the supports. And I'm going to have to take a note of where I put that so that I make sure that I'm, again, not carving over my supports. Now, this might leave a border around the outside that we can then take off with the bandsaw if we need. This will save us some time by doing it this way. There we go, got my border. Now for the tool path, I'm going to highlight everything this time. Go to V-carve just like we did before, and I'm going to make sure to set the start depth at 0.1 and the flat depth at 0.1. This is actually going to allow the two pieces to have a little bit separation when they are put together, and that separation will allow us to run the bandsaw through there to actually cut these apart once we're done. So 0.1, 0.1. I'm going to use the same tool, that 60-degree V-bit, but I'm also going to use a flat area clearance tool. This is going to just speed things up and get rid of all this stuff that is just going to be flat. So I'm going to select, I have a 1/4 inch end mill here that I'm going to use for that. Right here. So there's my 1/4 inch end mill that I'm going to use to flatten out the bits that are going to be flat. So let's calculate and preview. And you can see how it's going to create that mirror image that should nestle in. This stuff around the outside, we're just going to cut off with the bandsaw so that it sits flat when it's in there. All right, now that we've got our tool path ready, it's time to take our pieces, our bits, and actually head over to the machine. All right, so I got the program open here that's going to communicate with our CNC router. I've opened up my first set of code. I'm going to do the pocket first. So we're going to open that one up. And now I just need to zero my machine. I'm going to use the controls here to get this router right down here at this point. go through and actually kind of knock off some of this stuff that's just a little bit, you know, not quite as smooth. We can even like sand it out if we want. This is looking pretty good though. I might dust it off. And now, moment of truth. Let's take it, flip it, and line it up. Oh, I'm so good at lining things up. There we go. It's locked in, and you'll see there's a little bit of room, so once we glue it, we'll be able to take the bandsaw through there to saw it off. Now, we just need to put the glue in there, make sure we get glue in all the grooves, so that once we cut this off, every little piece sticks in there nice and snug. All right, let's get to gluing. Got our glue in there. It's okay if it's a little bit messy because we're going to be sanding it at the end. So let's sandwich them together. One last look. Make sure all glue is in all the spots. We'll press it into place. Because we left those little pockets, there should be a little bit of room underneath. And now we just got to clamp it, let it dry, and then next we'll bandsaw and sand. Now, once the glue is set, we'll take the clamps off. It's going to take a couple more hours, but you see how by putting the start depth and pocket depth where we did, it left that little gap. That's going to allow us to run it through the bandsaw just like this, separating the two pieces. Then we just sand it to finish it, and we're done. All right, so here's what our final product looks like. Check it out. Thanks everyone for watching. If you want more information, more details, if you're just getting started, check out the materials we have linked in the description below. Thank you for joining us for Designing for CNC Manufacturing, CAD to Canvas.